Hello friends, in the last video we have seen about shallow foundations and also we have seen about the how to find the bearing capacity of the shallow foundation. Now in this video we will start a new chapter called deep foundation. Deep foundation. So coming to the gate exam, definitely we can expect a 2-mark question minimum, a minimum 2 marks question from this topic. And yeah, that too, if you see the contents, so in this chapter we will study about the different methods that are used to evaluate the capacity of a deep foundation. Right? First of all, let us recall what is meant by a deep foundation. So if you remember, if your depth of the foundation, if it is greater than the width of the foundation, then we can call it as a deep foundation. So the best examples for this may be you can see piles, you can see uh, piers and well foundations. All this comes under deep foundation. Now, by the name itself, we can understand deep foundation. That means your foundation is very, you will dig into a very up to large depths, isn't it? Why we have to go for the large depths? So let me draw or let me show you a deep foundation by taking the example of piles. Suppose let us say I have constructed deep foundation by using some piles like this here, and the load will be applied on the pile. So in general, if a deep foundation is constructed and if the loads are applying on it, then this foundation that will fail by which type of failure? Already we have seen in the bearing capacity chapter, wherever it is a deep foundation, it will fail due to punching shear failure. What is meant by punching shear failure? The pile itself will drive into the soil without any disturbing the surrounding soils. Now, the topic is why we have to go for the large depths. Why can't we achieve a sufficient bearing capacity in the shallow foundation? That means at the smaller depths itself. Why we have to go for the very larger depths? So that's why let us say the necessity for the shallow foundation. Suppose if the loads are very high, if the loads are very high, and if your soil is not capable enough, then we have to go for the deep foundation. That means I will say if loads are very high, if loads are very high and soil is weak. If we are having good soil, then even though we are having very larger loads, then we can construct a shallow foundation. But if your soil is weak, still the loads are very heavy, then we have to go for the deep foundation. Next, for expansive soils. Suppose if you're talking about in expansive soils, you cannot achieve a bearing capacity. And that too, if it is expansive soil, the settlements will be very larger. If you construct a shallow foundation, even though the soil is having bearing capacity, it may not satisfy the settlement criteria. That's why if there is an expansive soils, then we will use the deep foundation. And any if there are any lateral loads acting on the lateral loads. So as of now, we have seen in bearing capacity only we have applied external load, that too truly vertical acting at the CZ. But if there is any lateral load, that means if I take any pile foundation and if there are loads, any lateral loads means other than the longitudinal direction of the foundation, we can say it is a horizontal also. So if there is any load that are acting in lateral direction, then to resist them, we have to go for the deep foundation only. And If you use the deep foundation, then zero settlements are also possible. So wherever you want to achieve zero settlement, that means very, very important structure, that is like nuclear power plants. Like if you want to construct any important structures, then there may be some requirement that settlements should almost be equal to zero. So if you want this zero settlement, then obviously we have to go for the deep foundation. Okay, these are the some important factors. Based on them, we have to go for the deep foundation. And also in the next video, we will see how to classify the deep foundation. Okay, thank you.